Hi everyone, my name is Neeraj Gupta. In this tutorial, we are going to talk about how we can use Python for data analytics and visualization. So first of all, Python, what is Python? Python is an interpreted and dynamically typed language and highly object oriented, and it is very adaptable and can be used for different purposes ranging from web development, web application development, creating testing and pen testing tools, to data analytics and data science. So it can be used to do different set of activities. Well, Python is basically formed on a tree of dependencies, which means there are several libraries and packages which can be imported in Python to do different set of tasks. For example, NumPy, Matplotlib, Pandas can be imported to do the activities such as data analytics and visualization. And for the purpose of data analytics, Python has packages such as Pandas, NumPy, Matplotlib, Seaborn, Scikit-learn for data analytics, predictive modeling, and machine learning. As I said before, availability of such libraries makes it very straightforward and easier to perform the analytics and predictive analytics and other related tasks, because users can use this to do the related tasks in very few lines of code. Python has become relatively popular for data analytics after the introduction of Pandas, which is a library for data preparation and data munging. Pandas can be used to collect and gather resources that are data sets from different sources like the websites, CSV, flat files, or SQL tables. We will talk about the libraries available in Python that we are going to use during the demonstration. But first, let's install Python and configure it. There are different approaches of installing Python on your system. For example, you can install Python from python.org/downloads. There are different versions of Python. The latest version is 3.6.1, and there is another option of 2.7.13. And if you want to see the differences, like what changes have been made so far in from the version 2.7 to 3.6, you can click this link here and see all the documentation of changes. And there are different ways of installing uh, Python on based on your system. So if you have Linux or Mac, you can follow the instructions from here, or since we are using Windows, so I will show you how you can install Python on your Windows system. So one approach is, if you want to download the package from python.org, you can click on download and the download will begin. You can install package called Anaconda. So Anaconda is available, developed and maintained by Continuum.io. So if you go to this website, you can find the link to download Anaconda. If you click on that link, it will bring you to the download option for Windows, for Mac, for Linux. So here you can select the version and the 32-bit or 64-bit installer. So if you click on 64-bit, the download will begin and an interactive installation will begin. Basically, the difference between the two packages is that uh, Python 3.6 comes with minimal packages that you can use to get started, and you can import or install the libraries in the future needed by you. And Anaconda comes with GUI, and it also comes with Jupyter Notebook. But in Python 3.6, you have to install the Jupyter Notebook yourself. Let's click on this executable file. So since I have already installed the Python 3.6 on my system, it will give me the modify or uninstall. If you are installing it for the first time, it will give you the option to integrate it to the Windows environment, so that you can access Python from your command prompt. Also, this package comes with pip, which is used to install the libraries and dependencies, which we will see in a while. And it has the Python test suite, all other things. So I will cancel. You can follow these instructions. It's straightforward and you won't face any problem installing. So if we click on this executable file, an interactive installation will begin. Click on next. So if you want to read the agreement, you can go ahead. I'm clicking on I agree, and you see here it is Anaconda 3 version 4.3.1 64-bit. Click on I agree, and you can select if you want it to install for just yourself or for all the other users, which will obviously require admin privilege. Click on next, give the path, check this box, add Anaconda to my path environment variable so that you can exit it from the command prompt. You can read it here. Click on install, so it will install everything you need to get started. You can, the good thing about Jupyter Notebook is you can also save your file in the notebook format. So if you do that, you can import this file in any other system, or from the download in this format from the internet of is already created or an created file which has some in work analytics or data science related work, and you can make changes or do anything with that file, or you can save it as a Python file or as a HTML file or as a PDF. So now let's go ahead and look at how we can import data from the sources. So for that purpose we are going to use pandas. As we talked before, pandas is a library that is used for collecting data and importing data into data frames and cleaning the data. That is data mixing. You can make the subsets of data, you can group data together, you can change the columns, you can work around with rows using the pandas. So first let's take a look at let's go to website for pandas.io so that you can know what kind of files you can import and what files can you export to. So Panda has functions called read CSV, so you can use this function to read from the comma separated files. You can also read from the Excel files, you can read from the SQL, you can use JSON, you can use the HTML. So using this you can actually import data from websites like Quandl, Yahoo Finance, Google Finance. You can use import data from the SaaS projects or from the clipboard, or you can use the pick, and you can export to CSV, Excel, SQL, and other formats. So let's go back and import pandas as PDs. Another thing or library we need for this demonstration is Seaborn for the data visualization, and sklearn to do the linear regression. We also need date times to work around the dates, because our data frame will contain the date as the index. Once we have all the dependencies imported, so when you hit enter you have a star in the array here, so this means your command has executed with no error. Okay, so the next step we will do is we are going to import data from Yahoo Finance from starting date 2010 11 to and in setting the end date to 2015 1 and let's hit enter, and we are going to import data of Apple with the abbreviations of Apple and Microsoft, Amazon, Sony, Google, FB using panda data reader.get underscore data underscore yahoo. We will just collect the adjacent closing price of each companies and store it into a variable called stocks, and we will set the index to none. So we will see what this means in a while. So since once the variable is created, we can see the data frame that contains data as index and the company's adjacent stock closing price in each columns. So the Apple's stock price, Amazon, Google, Microsoft, and Sony. So stocks.head, what it does is it will show you only first 5 rows of the data frame. So this way you can see, it makes it convenient to see your data frame, how it looks like. If you don't have this, if you remove it from here, just do that and click on enter, you can see all the data, which is again the program actually hide some data and show you the first certain rows and the last certain rows. So let's keep the head function here and see the only first 5 rows, and if you want to see last 5 rows in your data frame, you can type stocks.tail, so it will show you the last 5 data rows from your data frame again. And also if you want to see the last 10 or last 15 or last 20 frame rows from your dataset, you can type tail.10 or first 15 head from the head, it will show you accordingly. Okay, if you want to see the shape of your data frame, you can enter stocks your data frame variable dot shape, so it will show you how many rows and how many columns you have. So this data frame has 1833 rows and 5 columns. And also if you want to see the index of your data frame, you can click stocks.index. It will show you the index values in your data frame. So since date is the index of our data frame, so we have the index given as this. And if you want to see the column, you can see the column name all over here, and the type is object. Also you can see the values of your data frame by typing stocks.values, so it will show you the values stored in your is column and so on. Also so till now we have like 5 columns in our data frame. So what if we want to see only 2 columns and store it into a variable? So for that we have dot log, so which means the location. So you can give a location followed by a bracket and column and your very column names. So and let's click enter and let's comment this first. So it's executed, and when we want to see this, now our these two columns are stored into a new variable. We are not going to change this one. So we now let's take a look on stocks underscore 2 dot head. So here you can see all other the new variable has only two columns, Apple and Microsoft. So if you want to change this and add Amazon, for example, so now you have Amazon replaced, which replaced the previous one. Again, um, so if you don't want the date here as the index, you can actually reset the index by whichever data frame we want to reset the index of. So for in this our case, I'm going to reset the index of table data frame 2. So data frame name dot reset underscore index, and it will. So here you can see now there is a new index automatically created, and the date field is not an index anymore. So if you want to remove the date from your index and use it as something different for according for your requirement, you can do that using this command. And again, okay, let's we can again group the dates, the values and the dates. Let's create a group. We'll use the pandas datetime index on stock2 dot index, and then we are going to use group by function and store it into group dot underscore raw and see the value data frame. So once we you can see there is no any change so far from previous one. So we need to use a function mean here. So now you can see that date is grouped by the year. Now our new data frame is grouped underscore raw. So okay, so you can group your data and you can change your data using different functions that are available in pandas. So so far we have been doing our the data munching stuff on the stocks, which contains all the adjacent closing prices of all six companies. What we can do further is we can see the variables or the data frame of each company. So for example, if we want to see the data frame of Apple, so the Apple has a date, open, high, low, close, and adjacent close. So we extracted all the adjacent close in and stored of all companies and stored that into a separate data frame that is stocks. Now if we want to see just the adjacent price of Apple, we can do that by creating a new variable and assigning apple.location and the adjacent closing price. So we have a new data frame here with date and adjacent close. If we want to do that for Google, we can do the same. So for Google, we are trying to take the closing price. So let's do that. So now we have another data frame that is Google underscore close dot head close. So we have the closing price of Google here. Okay, and again we can see the tail last 5 columns, the rows of the Apple variable data frame. Also we can see the last 10, and we can concatenate. So for example, you have two different data frames and you want to add or put together their values so that you can do certain analysis. It will try to merge together the values or the rows from the two data frames where the columns are similar. So for example, in our data frames, all the data frames have the same column name. So if we try to merge Apple and Microsoft together, it will put the 5 columns as this, and we'll just add the values below. The topmost values would be of Apple, and after that the concatenation will add the values from Microsoft to on below. So let's try to see that. So, and if we again try to see, let's copy this and dot save. So we have 33666, and again, so we concatenated Apple with Microsoft. So let's try to see what we had, what was the shape of Apple before we concatenated them together. So Apple dot shape. So we had 1833 in Apple, and now after the concatenation we have 3666. So let's now plot our first graph. So to plot our a basic graph, you can just put the variable name that is your data frame dot plot. We are assigning figure size as 10:7, so 10 is the width, 7 is the height. So our graph kind of looks like it is basically a line graph. So you have the years and the as closing prices, and you have a legend here, and you can also use the secondary Y value. Let's just use Microsoft for now. So you see you have a secondary Y value of Microsoft on this axis. So you can use this to analyze how the trend is moving up. What was the trend of stock price, adjacent closing prices of the stocks of these 5 companies. Further, we can also use a scatter plot. Okay, so we got that error because we are trying to get some value that is not existing in this data frame. So you can see here the key error is MSFT, so that is Microsoft, and our stock 2 does not contain that value. So our stock 2 has Apple and Amazon, it doesn't have Microsoft. So either we can change the Microsoft to Apple Amazon, or we can use another data frame, stocks, and we can plot the scatter plot from there. So the x-axis is Microsoft and y-axis is Apple, and you can see there the scatter plot on the basis of two x and y variables. So in this way you can modify your data frames, merge them together, concatenate, group the values, filter certain columns or rows. Further, what pandas allows us to do is we can get descriptive stat of the data frame we have. So for example, let's get a quick analysis of the stocks. So it has the stocks data frame, as we talked before, has 5 columns of adjacent prices of the companies and the date as the index. So it will show you a table or data frame with the count. So this is the count of Apple, and all have the same number of rows, actual values, and their mean, their average price of each company, their standard deviation and their minimum, maximum, and their quartiles. So you can do descriptive stats on your data frame using the describe function of available in pandas. So that was for the stocks data frame. So what if we want to do a different data frame, that is say for Google, that contains the adjacent closing and so on. So let's go ahead and do that. So as you can see, we now have the stat for all the opening prices here, the high, the low, the closing price, the volume, and the adjacent closing. And we can do it for Apple. Don't describe. We didn't see any difference over there. Now let's do Microsoft. So yeah, you can see that the mean changed, all the values, the calculation changed. So this was the quick calculation of the standard deviation, mean, minimum, maximum, or quartiles. We can say to just calculate the mean or median or the standard deviation, or we can do our custom calculation. So for example, let's do mean on the adjacent, just calculate the mean. So we have the average price of Apple, Amazon, Google, Microsoft, and Sony, and the data type is again float. Adjacent closing price of Apple is average price or the mean of that adjacent closing price. And we can also do, we have the closing price of Google, the data frame that only contains the closing price of Google in this data frame. So we have the average closing price is 673. So further we can calculate the median. So first of all, let's again do the median on the stocks that contains the all 5 columns of 5 companies. So we have the median of Apple, Amazon, that is 295, Google 443, and SNE 23, so that is Sony. And if we want to do again on Apple's adjacent closing price, we get 74. So that is the median of adjacent close of Apple. Now let's do that on closing price of Google. So closing average price of Google was 619 from in that time period. Again, we can do calculate the standard deviation on each data frames. For example, the standard deviation on all 5 adjacent closing prices of 5 companies. So standard deviation of Apple was 30, Amazon was 29, Google was 184, and so on. And again on the Apple's adjacent closing price, it was 30. Now again we can do on the close dot std. So the standard deviation of the closing price of Google was 159. So this way we can calculate some descriptive statistics stats using the functions available in pandas. We can calculate custom calculations. So for example, we want to get maximum the minus the minimum value of the stocks. So we are using the numpy array, that is and the cumulative sum function. And so you can see that the maximum minus the minimum of all the 5 companies over here. To calculate the same calculation on Apple's adjacent closing price, max minus min of Apple adjacent closing price is 119.88. We can also calculate the linear regression. Say we want to calculate the linear regression of the stock data frame and first 5 rows. So we can do that by we imported linreg from the scikit-learn. linear model import linear regression and named as LinReg. So we have our index, linear regression of Apple, Amazon, Google, Microsoft, and Sony. We can also calculate linear regression on just one, the Apple's adjacent closing price from that data frame. That was the calculation of linear regression. So in this way, we can use the linear regression function from available in scikit-learn to calculate the regression. We can also further calculate the correlation coefficient from the uh, data frames, and we can also give the column indexes. So we are using the NumPy NP from the NumPy and correlation. So let's enter and see what happens. So the correlation between 1 and 5, that is Apple and Sony, their correlation was 99.99, which is positive correlation. Let's try to change this value, set this to Amazon and this to Google. Now let's see there. So they have also similar kind of correlation, and say 5. They do all have positive correlation. To plot, we can use Seaborn, that is a library for visualization in Python to plot the graphs and charts. So we let's hit enter here, and as you can see, we are using Apple and Microsoft has two x and y variables. So Apple is the x variable and Microsoft is the y variable, and we are using the data frame stocks, and this is the size of the figure. We can change the size of the figure from here, as you can see, and we are using the kind here, that is the type of the chart we are using in SNS pair plot, that is a regression, that which gives us, if we remove this from here, we get only the plotting of their values. Kind equals to race. Okay, so that was one way of plotting the linear regression of two values. We can also do some predictive analytics. For this purpose, first we are going to take the date time from the stock index and put that into times using the pandas date time index, and group them by year into a group row and aggregate them to get only the year. Now since we have the grouped index value of the data frame, so we are using the grouped data frame here. Now to plot the diagram, so we are using PLT from matplotlib dot figures. So we define the figure size here, and PLT dot plot grouped the data frame, and we are taking Sony from the grouped data frame, and we are giving the title as adjacent plot is closing of SNE, and we label X label as year and Y as the closing price, and PLT does so. So we have now the trend line of Sony from 2010 to 2017 according to the value given in the data frame. So we can do some analysis in here that in 2010 the price was at 32 point, a little bit above 32.5, and the trend was declining, and it was very steep till from 2011 to 2012, and it began to rise from 12 to 13 and was linear till 14, and the rise was again, and it again inclined to rise with higher speed till 15, and so on. As you can see from here, to do some prediction, first we are going to take the group data frame, index the values, and reshape it as -1 and 1. So that means we are going to arrange the arrays in this order. So and put them in the variable x, and we are going to group this column Microsoft.values in y. So we are basically taking the date and the values from Microsoft from grouped data frame. So to calculate, let's click and enter, and it's executed. Now let's take function linear regression in arrays, and let's fit xy using linear regression by calling the function fit on x and y. And in y underscore prediction we are going to do regression, that is linear regression dot predict, that is the function available in scikit-learn, and you put in the variable. So we grouped the date as x, so the x is the variable, so we can give any value in for example say 2025, 2030, so to get a general idea of what will be the trend of this line moving, will it be going upward or downwards, we are going to do a simple prediction of that. Raise regression.score will calculate the confidence level from the date we provide for the prediction and put that in CI. So that is the confidence interval. Let me remove this, and we can say it as accuracy of the prediction and print it as a string. So let's hit enter, and we can see our accuracy is 93%. That is not that bad. If we get the prediction around 30 or 30-25, we could say that the confidence level is too low and we would not be sure that this predicts to trust. Well, now let's plot this on a graph. So as you can see, we have a trend line. This is the graph. We had data till 2017. So what if we want to know is the stock price is going to move upward or going to fall down? So we can give some put in some years. So first, say for example 2025 and enter. So we have the value as the price is going to be 108 in 2025 according to this trend, and in 2020 the price would be 77. So according to this prediction, our price is going to go upwards. Seaborn has several options, so you can plot pair plot or regression plot. So say for example we want to um, plot a regression plot using the variable x and y we calculated and put the color as red, and CI as the confidence level, and put the scatter as true. So we can do this, use just one line of code and plot the trend line and the scatter plot. Let's do the pair plot on x variables containing three columns, like three adjacent closing prices of three different companies with and their correlation with Sony. So that means Microsoft correlation with Sony, Apple's correlation with Sony, Google's correlation with Sony, and let's keep the aspect this as 0.7 and the kind to be regression. Since this is a pair plot, we have to mention that this is a regression. So you can see here that the y variable is Sony, and in the first diagram the x variable is Microsoft. So the the trend line is moving upwards between the correlation between Sony and Microsoft is slightly is inclined upwards. That means the faster, according to the growth or increase in the price of my Sony, so the stock price of Microsoft will increase. But as you can see here in Apple and Sony, the trend line is almost horizontal. Again, in the Google and SNE, the trend is upwards. So again, we can change these variables. So for example, if you want to put Amazon, or let's Microsoft, let's keep it that way and change it to Amazon. Let's see how is their correlation. What is the correlation of Microsoft, Apple and Google to the stock SSN stock price of Amazon? So as you can see, it's steeply inclined upwards. So if when the price of Amazon goes up at the same rate, the prices of the Microsoft goes up, my Apple's price goes up, and so on. Basically, we can use different libraries in Python such as pandas, NumPy, Seaborn, um, sklearn, that is scikit-learn, datetime, and matplotlib to import data, work with the data frame, do the data merging, plot the diagrams, calculate linear regression, calculate descriptive statistics. So there are several. These were a brief demonstration of what you can achieve using Python for data analytics and predictive modeling. So if you want to learn more about um, data analytics using Python, you can use, there are so many tutorials and lessons. You can find data frames on Quandl or Kaggle. So you can search data from frames from here. So for example, say you want to get the, you can go to this website, search for the datasets for the notebook, or you can download the notebook and import it into the Jupyter notebook. And so for example, I want to fork this, and now I can work on this notebook. So this is the feature of Jupyter notebook, that you can work on a live website like a SaaS application. You don't have to install anything. You can, if you want to do the calculations or something like that, you can go ahead, import the libraries, and it's just work like you are using it on your own system. So you can change Python. This is the Markdown. So here you can import the data, and see, as you can see, it's works just like you are using Jupyter on your own system. So yes, you can also find the different data sets. You can search for data sets. So you can register in this website, and there are several other websites like Kaggle and Quandl, where you can import datasets using by creating an API. So and you can find different tutorials to learn about data analytics using Python. So I hope this tutorial was um, educative, informative enough so to get you started. And thank you so much for your patience. See you next time.